Okay, we're going to start chapter 5, section 2. We're going to discuss logarithms. All right. This particular video is going to be pretty short just because I'm only going to do the part of this lesson that's going to be on your upcoming quiz, right? So I am just going to convert between logarithmic and exponential functions. All right. Before I do that, I just want to explain a little bit of what's going on here, right? So I kind of want to talk about what a logarithm is. Before I do that, let's just recall some examples of inverse functions, right? So you guys, whether you know it by that name or not, you guys know a couple of inverse functions, all right? Some examples of inverse functions is if I have a multiplication, I know that the inverse, or whatever undoes a multiplication, is division. All right. Similarly, if I have an x squared, I know that the opposite of squaring something is square rooting something, right? So that's kind of the idea that we're going with here, right? We already know what a to the power of x is, all right? The inverse of this is going to be log base a of something, all right? That relationship is defined here, right? So we can go back and forth between logarithms and exponents, right? But what I wanted to kind of target here is that exponents and logarithms are inverses of each other, right? They're opposites, all right? I kind of want to discuss first the exponent part of it, right? So you guys are familiar with this notation here. So we read this as a to the power of y equals x, all right? And in this case, a is our base. We say y is the exponent. And then I can just say that x is whatever this equals. So I'm going to say that this is the answer, all right? Now, if you look where it says y equals log with this a and the x, you actually see all of the same things as you would have seen in the right-hand side, right? So I still have an a, I still have an x, and I still have a y. We read this as, or I'm going to say we read this portion of it as log base a of x, all right? So in this case, the little number, in this case, this number right here, this is our base. And then notice we have this y in the exponent. That's what it equals, right? So this is our exponent. And then we have that x shows up on the right-hand side as the answer. But in this case, it's on the inside. So I'm going to say that log base a of the answer is y, all right? So you can kind of go back and forth between the two, right? So for instance, if I had 2 to the power of 3 equals 8, all right? What is your base? Well, your base is 2. What is your exponent? It's going to be 3. And then what is your answer, right? Your answer is 8. I can go ahead and rearrange this and say log base 2 of my answer equals the exponent 3, right? One way that you can remember this is bay, right? Base, answer, exponent, right? When you're converting it from exponential to logarithmic, that's what it would be, right? So I have an exponential equation, right? So this is in exponential form. And then I have this right here, which is in logarithmic form, all right? So you can always go back and forth between the two. Another thing that sometimes some people like is I told them circle the base and then point to what it equals and then loop back around. And then that's going to get you the same thing, right? If I circle the base of 2, raise it to the power of 3, that equals 8. All right. Similarly, 2 or log base 2 of 8 equals 3. All right. Might be a little bit confusing, but I'm going to show you a couple examples in the next slide. Hopefully it kind of solidifies this idea of a logarithm. All right. This is the only slide that we're going to do in this lesson, right? We're not going to go anything past this just because this is the only topic that's going to be on your upcoming quiz, all right? So the directions say convert from log to exponential or vice versa, all right? Now, this first example we kind of already did, all right? I'll start by just writing out how you would read it, right? So I'm going to say that this is log base the little number, right? So our little number here is 2, log base 2, and I'm going to say of whatever is on the inside, so of 8 equals 3. All right. Now, a couple ways that you could think about it, right? I want to convert this from log to exponential. All right. How do I know? Because we see a log. All right. That's how you know it's a logarithmic equation, right? So what we're going to do is, one way to do it is circle the base like I just did with the 2, raise it to the power of whatever it equals, and then equal it to whatever's on the inside. So we get 2 to the power of 3 equals 8. Another thing that you could do is label the b, the a, and the e, right? You can use bay, right? Your base is 2, so that means if it's the base in the logarithm, it's going to be the base in the exponent, right? Base answer, so I know it has to equal 8, equals e, the exponent, so I know that 3 has to be up top. But either way, we should get 2 to the power of 3 equals 8. All right, that's all we're doing here. All right, and you can always confirm that this is a true statement, right? If I did 2 times 2 times 2, I do in fact get 8. That's all we have to do, right? I'll do a couple more, and then hopefully you get the idea. All right, again, this is a log equation. I see a log. Our base is 1/2. So that means I know in my exponential form, I'm going to have 1/2 to the power of something. What is that something? We'll draw the arrow. It's pointing to the -4. So I know 1/2 to the -4 has to equal 16, right? Loop all the way back around, and that is your equation in exponential form. All right, again, that's all you have to do. I know we see a negative exponent. You might be tempted to simplify it, right? Don't, right? All you're doing is rewriting it, right? That's all I'm asking you to do. All right, now let's try the same exact thing with the next one. All right, so this is read as log base 10 of 100,000 equals 5. So I'm going to do the same thing. I'm going to circle the base. The base is 10. Draw the arrow going all the way around. It's going to be 10 to the power of 5. And this equals 100,000. And this is my equation in exponential form. All right. Now, if you look at the rest of these examples, none of these have a log in it, right? Which is perfectly fine, right? That just means we're going to convert it from exponential to logarithmic, right? So I'm going to do the exact same thing, right? What's our base here? Our base in an exponential expression is whatever has the exponent. So I'm going to write a log, and our base here is 5, and I'm going to do the same thing. I'm going to draw an arrow. It's going to be log base 5 of 25 equals your exponent. And your exponent in this case is 2. All right, that's all we have to do. All right, let's try the same exact thing with the next one, right? What is our base here? All right, our base is 3, so I'm going to circle the 3, and this is going to be log base 3, so it's going to be a little 3 of 1 over 81. Just so that it's not confusing, you can write parentheses, right? 1 over 81, and then it's going to loop back around, and it's going to equal -4. All right, so we get that as our answer in logarithmic form. All right, let me actually fit that a little bit better. Equals -4. All right, do the exact same thing with the next one. All right, so I'm going to take the base. The base in this case is 3/4, so I know that this is going to be log base 3/4 with the little 3/4. Draw the arrow. It's going to be log base 3/4 of 1, and it's going to equal the exponent 0. So again, in all of these, you can think of it as base, answer, exponent. So bay is fine. you can just draw the arrows. One other thing that I learned, right, when I was in college algebra, when I started college, the professor said something kind of sticks, right? Bases are bases, meaning if it's the base in an exponent, it's going to be the base in a logarithm. And then she said the other two switch places. The other two switch places, right? So the other two numbers are going to swap places, right? Which is kind of what I drew in this little arrow, right? So for example, the base here is 3/4, right? So it's going to stay the base right here. And then the other two, in this case, the 0 and the 1, are going to swap places. All right, so little rhyme if you want to think of it that way. If you like a little rhyme to think about these problems, or again, draw the arrow or label the base answer exponent, right? So that's 3 different ways that you can think about these problems, all right? But that's really it. That's it for the sake of your quiz, right? I'm going to finish these notes for the sake of your test, but this is all you need to know for now.